Hello and welcome to PreCalc Honors. We're going to get started this year with the first video in our textbook. This is chapter 1.1. It's an outline of the chapter Functions and their Graphs. So let's take notes on this part of the chapter. First of all, we're going to talk about something that I hope was covered slightly, at least, in Algebra 2 last year, which are called parent functions. Your mom and dad might like parent functions. First of all, there are a couple of them that we're going to cover today. There are many parent functions, but the first one that I'm going to cover is something called a constant function. Oops, I can spell. A constant function. A constant function is in the form of f of x is equal to c. And c is called the constant, c for constant, and a constant is any real number so any real number. It can be positive, negative, radical, fraction, decimal. It can be anything. For example, if you have f of x is equal to 4, that's a constant function. And if you wanted to graph this, because we're going to talk about the functions and their graphs both, if you wanted to graph this, this is just like graphing the function y equals 4. So we'll set up a little mini xy axis. And f of x, which is the same thing as y, f of x equals 4, you can just make a horizontal line, label it f of x is equal to 4. If you want to put 3 little tick marks here to indicate that you're on the fourth line up. A constant function, the graph, is a horizontal line. This shouldn't be new to you at all. The second parent function that we're going to talk about is called a linear function. And there are 3 forms of a linear function that we're going to talk about. Linear functions come in 3 forms. The first form of a linear function is called slope-intercept form. And this is the form that you probably talked about the most when you were in Algebra 1. This is in the format of y is equal to mx plus b, or in other words, f of x is equal to mx plus b. And if you've forgotten what they all mean, m is the slope, and b is equal to the y-intercept. So those are the 2 parts. And x and y are just any variables. So for example, y equals 3x minus 2 is a linear function. And a linear function, the graph of that is just a diagonal line. So if you wanted to graph y equals 3x minus 2, my lines are all that straight. Here's x and y. You have a y-intercept of -2, so you can just put a little dot on -2. And the slope is 3, which means you're going to go up 3 and over 1. So the next point would be 1, 1. And then if you wanted to just take a straight edge, or just try to draw a straight line through that, here is your y equals 3x minus 2 with a couple of points on it. So that's the slope-intercept form of a linear equation. The second form of a linear equation is called standard form. Still a linear function, but in standard form, it goes like this: ax plus by is equal to c. Now, a, b, and c are just any real numbers. For example, you might have something like 3x plus 5y is equal to 15, for example. Now, if you wanted to graph this, usually you'll just find the x-intercept by setting the y value equal to 0. And then you'll find the y-intercept by setting the x value equal to 0. So to find the x-intercept, you let y equal 0 and solve for x. So that would go like this. 3x is equal to 15, so x is equal to 5. So that means 5 comma 0 is the x-intercept. And to find the y-intercept, you just set y or x equal to 0 and solve for y. So in this case, if we let x equal 0, we get 5y equals 15 from the original problem, so y is just equal to 3. So that will give you 0 comma 3, which would be your y-intercept. So once you have an x-intercept and a y-intercept, it's pretty easy to graph because all you need are 2 points. And the 2 points are 1, 2, 3, 4, 5, 0, and 0, 1, 2, 3. So here would be your graph of that 3x plus 5y equals 15. So that's the second form of a linear function. And then we'll go on to the most important form of a linear function that you'll use this year. You might have thought that slope-intercept form was the most important, but it's actually not. The point slope, and I'll put a little star next to this because this is the most important form. The third form of a linear function, point slope form. And point slope form goes like this. Y minus y1 is equal to m times x minus x1. And what these variables mean, just like in a slope-intercept form, m is equal to the slope, and x1 comma y1 is any point on the line. Any point that you can locate on the line, you just substitute those two x, y values in for these two values here and substitute the slope in, and then you've got a point slope form of a linear function. So let's go through a little example of point slope form. You might have done this already in another math course, but since it's so important, let's go through an example. Let's say we have to write a linear function. In slope-intercept form, passing through 2 points. Let's say we're going to pass through points -1 comma 4, and let's say 4 comma -1. So we've got 2 points on the line, and we're going to write the linear function in slope-intercept form. No, we're not going to do slope-intercept form. We're going to do point-slope form. Sorry about this little mistake here. That's because we're talking about point-slope form. Let's do point-slope form. We've already done the other way. So point-slope form, passing through that. So first, you have to find the slope. And if you remember the slope formula, the slope is rise over run, which is y1 minus y2 over x1 minus x2. And in this case, it's 4 minus a -1 all over -1 minus 4. I'll just call this y2 or x2 y2, and we'll call this one x1 y1. So oh my gosh. So we're going to call this x1. I don't know why I did it in reverse. Y1, and this one is called x2 y2. So we have 4 minus -1 all over -1 minus 4. So the slope is 4 minus -1 is 5, 1 minus -4 is -5, and the slope is -1. So hopefully you've got this all cleared up. This is x1 and this is y1 and this is x2 and this is y2. So we first have found the slope, and then you can use either of these points, either this one or this one. So use either given point for x1 comma y1. So I guess I'll just use this -1, 4 for my x1, y1, and we're going to use the point slope formula. Y minus y1 equals m times x minus x1. That's the form of it. And that gives you y minus, now y1 is equal to 4. The slope we found was -1, so x minus and x1 is -1. Put that in parentheses. So that'll give you y minus 4 is equal to -1 times x plus 1. So you can leave it like that if you want to. Because this is the point slope form. Y minus y1 is equal to m times x minus x1. If you want to, you can go a couple steps further and turn it into slope intercept form, but it's not necessary. All right, you can just leave it like that. And then the last thing I want to talk about is something that you probably learned once and remembered, and that is that parallel lines have equal slopes. So we're done with the three forms of a linear function. I guess we'll just put a little end note here that linear functions have a graph that is a slanted line or a diagonal line. It's not horizontal, it's not vertical, it's slanted. So it either goes up or it goes down, positive slope, negative slope. So those are the linear functions. And now a couple things about linear functions. Like I said, parallel lines, P-A-R-A-L-L-E-L, parallel lines have equal slopes. For example, y equals 4x plus 5 and y is equal to 4x minus 2. These are parallel because they both have a slope equal to 4. Perpendicular lines have negative reciprocal slopes. So for example, y equals 3x minus 1 and y is equal to -1/3 x plus 8 are perpendicular because this slope is 3 and this slope is -1/3. They are negative reciprocal slopes. So the slopes are 3 and -1/3, which makes them perpendicular. And then a couple other notes about lines. That is horizontal lines. I think we already said it on the other page. Horizontal lines have a slope equal to 0. For example, y is equal to 6. That's another word for a constant function. A horizontal line is another way to graph a constant function. And then vertical lines have an undefined slope. For example, x is equal to 7 is a vertical line. Vertical lines go up and down, horizontal lines go left to right. And undefined slope is also, in other words, the slope is infinite. So this is not a function. Everything else we've talked about is a function. Vertical lines are not a function. Horizontal lines are functions. Linear functions, of course, are functions. They all pass the vertical line test, but the vertical lines do not pass the vertical line test. So that's about all I have to say for today. Pretty straightforward, pretty much a review of other things you've learned in previous years. Sorry about all those mistakes that I made on page 2, but we'll get through this. See you tomorrow. Bye-bye.